Alright, so I think this is recording. Let's take a look at our most recent quiz. We have been looking at, in skill packet 3, relations and functions, and specifically for this subskill, we're looking at the operations on functions. Given two functions, if we just call them f and g, we can use f and g to create new functions. We can do the normal operations that you're familiar with: addition, subtraction, multiplication, and division. And then today we were talking about function composition. But in this problem, they're asking us to multiply. Well, we don't have to find the expression itself, so I guess we don't have to multiply f and g together. What we want to do is find the domain of the function that would result had you multiplied them together. So to find the domain of this new function f times g, all we have to do is find the domain of f, find the domain of g, and intersect those two domains. So to find the domain of a function given an equation, it's always the same consideration. You can't divide by 0, and you can't take the square root of a negative number. Well, when we look at function f, we don't have any variables in a denominator, so we don't have to worry about division by 0. But we do have an expression that's underneath an even radical, a square root, and this x minus 3, it has to either be 0 or positive in order to take the square root of it, which means the value of x that we want to plug into this function to have in the domain are values of x that are bigger than or equal to 3. So let's draw a picture of that down here. And let's illustrate 2, 3, 4. I'm saying that if you plug in values that are equal to 3 or larger than 3, you'll be able to take the square root of it. You'll have a value. If you want to evaluate this function at 3, then you can take the square root of 3 minus 3. The square root of 3 minus 3 is 0, and the square root of 0 is 0. So we say that 3 is related to 0. If I want to input 4 from the domain into this function, then I'll have 4 minus 3. 4 minus 3 is 1, and the square root of 1 is 1. But if I pick numbers like 2 that are not in the domain, then I have 2 minus 3, and 2 minus 3 is a negative 1, and that's undefined. I don't have a y value, so I can't have 2 being in the domain, and that's why we didn't shade it. Alright, we're going to use this answer to help us get our final answer. We now have to look and see if we can find the domain of g. Well, the domain of g is a little bit easier because, again, it's the same two considerations. We can't divide by 0. We throw out all values of x that would cause division by 0. There's no variable in a denominator, so I don't have to worry about 0. And there's no even radicals. There's no square roots or fourth roots in this. So the domain of g is all real numbers. Okay, the domain of g is all real numbers. So if I just take the same window, the same part of the number line, but here for the domain of g, everything is shaded. Alright, so here it gets to, we use these two sets to determine our answer. If they're asking us to find the domain of f times g, we're going to take the domain of f that we found just a minute ago with a greater than or equal to 3, and we're going to intersect it with the domain of g. Now this operation of intersection, we can think of it as and. You have to be a member of this set in the shaded region, and you also have to be a member of this set. So both of them simultaneously. So that's the idea of an intersection. Alright, so let's draw a picture of what our answer is going to look like. The domain of f times g well, we can see that 3 is shaded in both sets. It's shaded in the top set, and it's shaded in this set, so it's shaded in the answer. But to the left of 3 is not shaded in here, so it's not in here and in here. It's not in both, so it can't be in the intersection. To the right of 3, all of these numbers belong to this set, and to the right of 3, all of the numbers belong to this set, so therefore they'll be in the intersection. So even though we did not find an expression for f times g, we can talk about that we know what the domain is. The domain of f times g is from 3 to infinity. So it is choice B. All right, so now we're gonna use our work in the next part. Okay, so let's carry our picture that we found for the domain of f and the domain of g onto the next part of this problem. So in part Roman numeral 2, we are finding the domain of a new function, f divided by g. So like I say, we're going to use the domain of f and intersect it with the domain of g, but in order to find the domain of f divided by g, we're concerned about g being in the denominator. We know that that the rules of arithmetic do not allow us to divide by a negative number. Take any calculator, and if you try and divide by 0, you'll get some type of an error message. It will not give you an answer. Here on this Texas Instrument, it says error divided by, well, the abbreviation for error, divided by 0. It's not going to allow us to do it. To find the domain of this new function, even though I'm not finding the equation itself, I'm going to find the domain of f, which I've already done, intersect it with the domain of g, which I've already done, and I have to consider that this g of x, I do not want the output of this function to equal 0 because it's in a domain, it's in a denominator, and division by 0 is undefined. So let's take a look at what the function g is. The function g, everywhere I see g of x, I can replace it with x because they're equivalent. This equation says they're equal to each other. So by substitution, if I want to prevent g of x from equaling 0, then I need to prevent the input into g from being 0. So when I look at this, let's draw that picture. The values of g of x that we can use that will have an output that is not 0 is to exclude the value x equals 0. Well, x equals 0 is to the left of 2. It's over here somewhere. Okay, and then here's the 2, the 3, the 4 on my number line that I have on here. So I want to exclude that value, but everything else is okay. None of these other values will produce an output for g that equals 0 that causes division by 0. All of these other numbers, because look at what g is. It's just the identity function. Whatever you plug in, you get the identical thing out. So if I'm trying to avoid a 0 in the denominator, and if the input is equal to the output, I'm just avoiding the number 0. So now I intersect these three sets to get my final answer. And I can see that 3 is in all three sets. I know that 3 is going to be in my intersection, but to the left of 3 is not in this top set, so it can't be in all three, because to be in the intersection of these three sets, the number has to be shaded in each set. 3 is in this top set, and it's in this middle set, and it's in this set. And so are all the values to the right of 3. But the values to the left of 3 are not like the number 2 is in 2 of the 3 sets, but to be shaded in the answer, you have to be a member of all 3 sets. So my domain for this new function, f divided by g, is from 3 to infinity, which just happened to be the same answer as Roman numeral 1. Sometimes it'll be the same, sometimes it won't. So there, our choice is there at choice B. Now, in Roman numeral 3, we're still going to use our work that we did in part 1 and finding the intersection, or finding the domain of the intersection. Let me restate that. We're going to use the domain of f and the domain of g to intersect these two sets. That's going to help us to determine what the domain This time the f is in the bottom, the domain of f, g divided by f. It's going to be the domain of f intersected with the domain of g, intersected with, well, this f is now in the bottom, and we want to make sure that the output of f is not equal to 0. So just like last time, we added a third restriction here, and we're going to add a third restriction here that all comes from keeping the denominator from being 0. So this time, f of x, I replace f of x with the square root of x minus 3. I'm trying to prevent this value from equaling 0. If I square both sides, x minus 3, 0 squared is just 0 if I add 3 to both sides. So if I want to prevent the output of f from equaling 0, I need to prevent the input into f from being 3, because 3 minus 3 gives me 0, and the square root of 0 is 0. So this third restriction that comes about to prevent this denominator, here's f in the denominator, to prevent it from being 0, we need to throw out the number 3. All of the other values are fine. None of the other values produce an output of f that's equal to 0, only when x is 3. 4 minus 3 is not 0. 5 minus 3 is not 0. Alright, so to be in our final answer, you have to be a member, you have to be shaded in all three pictures, all three number lines. That's the idea of intersection, the idea of this and this and this. So when we look at it, is the number 3 shaded? Is it a member of all three sets? Well, it's a member of the top set, it's a member of the middle set, but it's not a member of the last set. It can't be a member of the intersection. It has to be in all three to be in the intersection. To the left of 2 is not in the top set, even though to the left of 2 is shaded in the other two sets. The number 2 will not be shaded in the domain for g divided by f because it's not a member of all three sets. But to the right of 3, numbers like 4, 5, 6, numbers like 3.1 are all shaded in all three of these, so they're going to be shaded in my answer. So now to describe this shaded interval, that is the domain of this new function g divided by f is 3 to infinity, but you exclude the number 3. So it's different than the previous two answers, and that looks to be choice C. So I hope that helps with problem 1. I'll do problem 2 and 3 on separate videos. Talk to you later.